Here we go with problem number 58 from chapter 7. It reads, starting from rest, a 12 centimeter diameter compact disc takes 3 seconds to reach its operating angular velocity of 2,000 revolutions per minute. Assume that the angular acceleration is constant. The disc's moment of inertia is 2.5 times 10 to the negative fifth kilogram meter squared. Part A asks how much torque is applied to the disc, and then part B asks how many revolutions does it take before reaching its full speed. All right, so for part A, they would like us to find again how much torque is applied on this disc. We can use Newton's second law in the rotational version, which would be torque is equal to I alpha. And looking at this, we have I, but we do not know alpha. We'll plug in I 2.5 times 10 to the negative 5, but we got to find alpha. And we can do that because we know the differences in the changes in the angular velocity as time goes on and for how long. So we can say that omega sub f is equal to omega sub I plus alpha t. So omega sub f is going to be something we need to convert because we don't want it in revolutions per minute. We need it in radians per second. So 1 revolution is 2 pi radians, and 1 minute is 60 seconds. And that gives us an angular velocity of 209 radians per second. So we can plug this up here. 209 is equal to 0 plus alpha times t, which is going to be 3. So we find that the angular acceleration is going to be 69.8 radians per second squared. We can plug that in over here, 69.8. And we find then that the torque applied on our disk is going to be 0.0017 Newton meters. Part B wants us to find out how many revolutions it goes through. And those revolutions are related to the angular distance that it travels. So we can do theta is equal to theta sub O plus omega sub O t plus 1/2 alpha t squared. And we have 0 plus 0, because the initial angular velocity is 0, plus 1/2 69.8, and then times 3 squared. And that tells us then that we have 314.1 radians. But again, they want revolutions, so let's do that quick conversion. Right? 1 revolution is equal to 2 pi radians. And then we come out with it. The disk goes around 50 revolutions in that 3-second time period. So that was problem number 58 of chapter 7.